The average velocity with which electrons are moving from the negative to the positive terminal of a conductor is known as the drift velocity. It is in the order of 10 raised to minus 3 meter per second to 10 raised to minus 5 meter per second. Relaxation time is the average time interval between two successive collisions. It is in the order of 10 raised to minus 14 second. Consider a conductor under no potential difference. The electrons in the conductor are in a state of random motion, hence the current is zero. When a potential difference is applied, electrons experience a force and they accelerate towards the positive terminal. During the motion, electrons collide with the vibrating positive ions and they move along a curved path. Consider one electron, let its velocity just before a collision be u1 and its velocity just before the next collision be v1. Then vector v1 is equal to vector u1 plus vector a into t1. Similarly, for the second electron, vector v2 is equal to vector u2 plus vector a into t2, and for the third electron, vector v3 is equal to vector u3 plus vector a into t3. Then the average velocity is vector v1 plus vector v2 plus vector v3 plus etc. divided by n is equal to vector u1 plus vector u2 plus vector u3 plus etc. by n plus vector a into t1 plus t2 plus t3 plus etc. by n. Vector v1 plus vector v2 plus vector v3 plus etc. by n is vd, the drift velocity. Vector u1 plus vector u2 plus vector u3 plus etc. by n is equal to 0 because after each collision the velocities will be in random directions. The value of acceleration a is negative E divided by m, and t1 plus t2 plus t3 plus etc. by n is tau, the relaxation time. Therefore, drift velocity Vd is equal to negative E by m into tau. Consider a current carrying wire of a length L and cross-sectional area A. We know that I is equal to Q divided by T. If N is the number density, that is the total number of electrons divided by volume, then the total number of electrons is equal to N into volume, that is NAL. Hence, I is equal to NALE divided by T. L by T is the average velocity Vd, therefore current I is equal to NEA Vd. The drift velocity Vd is equal to EV by ml into tau. Vd is I by NEA, therefore I by NEA is equal to EV by ml into tau. V by I is equal to ml divided by Ne square A tau. That means the resistance of a conductor R is equal to ml divided by Ne square A tau. But the resistivity rho is equal to Ra by L and is equal to m divided by Ne square tau.